Hello, Matt, too. So this is a very important topic, ratios and proportions, as we head into this similarity unit. Ratio and proportions is something you probably did a lot in middle school. All right, so we are just taking it to the next level with where we're at. So let's get started real quick. So what is a ratio? A ratio is a comparison of two quantities. Now, you guys have probably seen ratios written in many different ways, right? Such as, you've probably seen them using the colon, the ratio of A to B, right? You may have seen it, the word A to B. When we deal with ratios, right, we're going to use in fraction form, all right, the most. We're going to say the ratio of A to B, okay? One thing about ratios you have to understand is that quantities must be in the same units, such as if I have 3 feet to 6 inches, we cannot reduce that ratio to 1 to 2, okay, because our units are different. We either have to convert feet to inches or inches to feet, okay? So again, the 3 ways we can express ratios, right, is 1, 2, 3, and the most common way we're going to do it is in fraction form. Okay? So, when we simplify ratios, all right, the first thing we have to check for is we have to make sure the numerator and denominator are common units. Okay? Then all we do is reduce the fraction. So, if I have 12 feet to 15 feet, right, these are common units, so now I could just reduce the fraction by dividing numerator and denominator by 3. 12 divided by 3 would give me 4 feet to 15 divided by 3 is 5 feet. However, the next one, right, if I look, my units are not common, therefore I have to convert either feet to yards or yards to feet. It's generally easier to go from big units to small units, right? Because all you're going to do is multiply and it'll always come out even. So when I look at a foot and a yard, which one is bigger? A yard is bigger. And we have to know 1 yard is equal to 3 feet. So when I do 6 yards, right, all we're going to do is take 6, and how many yards or how many feet are in a yard? 3. So 6 yards would be equal to 18 feet. So we are going to rewrite this as 16 feet to 18 feet. And now I can reduce by dividing the numerator and denominator by 2. And I would get 8 feet to 9 feet. Now, when you think about ratios, a lot of times you guys will hear like the ratio of boys to girls. And you'll think that the units are not common. But when I do, like, say the ratio of boys to girls in class is 10 to 12, so 10 boys to 12 girls, right? Although these aren't the same units, they both represent people, which is why they're considered to be the same unit. Okay? You're measuring people in both numerator and denominator. Now, proportion. A proportion is a statement that sets two ratios equal to each other, such as A over B is a ratio equals C over D. Right? Now, if we look at it, a lot of chefs and construction workers, engineers, they will all use proportions a lot. And if you look at what we've done with the project we just concluded, you use proportions without really knowing it. So, a proportion is a statement that sets two ratios equal to each other. And one thing you'll notice is if I take and multiply A and D, that product would be the same as B times C. How do we know this? Well, if I give you the fraction 10 over 12, and then I give you the fraction or ratio that's proportional to that, that would be 5 over 6. And if you think about it, this basically 10 over 12 reduces to 5 over 6, which makes them proportional. Now if I look at this, if I cross multiply one way and I cross multiply the other way, the cross products would be equal. 10 times 6 is 60, 12 times 5 is 60, therefore you know that these two ratios are proportional. So we know the cross products are equal, and there's all these different properties we could do, right? Such as if we flip A over B and get B over A, we have to flip the second ratio to make it D over C. Do the cross products remain equal? Yes. If I flip-flop, right? If I put C over here and excuse me, and if I move C down here and B up here, my cross products still remain the same. Okay, and then if I add the denominator to each numerator, my ratios still remain proportional. So, how do we solve proportions? Since the cross products are equal, we are going to cross multiply. But when you multiply one term times two terms, you must distribute. Such as if I have A over B equals C plus D over F, right? When I cross multiply this way, I have to do B times C plus D, which means I have to distribute. BC plus BD equals, cross multiply the other way, and I get AF. Now remember, when you do your distributions, there is a chance that you may get a quadratic, meaning you'll have x squared in your equation. If that's the case, you must set equal to 0 and then use the quadratic formula. Use the quadratic formula or factor. Alright, if not, you just solve like an ordinary equation. So let's go ahead and solve some proportions here. So when we cross multiply, I always like to cross multiply the way the variable is first. So I'm first going to cross multiply and do 2x times 3, which will give me 6x. Then I write my equal sign. I cross multiply the other way, right? Which gives me 9 times 2, which is 18. Now I just solve for x. Divide by 6. X is equal to 3. And if you think about it, 2 times 3 is 6. Does 6 over 9 reduce to 2 over 3? Yes. Therefore, the value of x that makes these proportional is 3. Now the next one. I'm going to start by cross multiplying this way first. So 8 times y is 8y equals, now I'm going to cross multiply the other way. But if you look, I have one term times two terms, so I must do 4 times y plus 3. So this gives me 8y equals, what's 4 times y? 4y. What's 4 times 3? Plus 12. Now I can solve this equation for y. Subtract 4y. I get 4y equals 12. Divide by 4. And y equals 3. And if I plug that back in, 3 plus 3 over 8 gives me 6/8 equals 3 over 4. Does 6/8 reduce to 3 over 4? Yes. So the value of y that makes these fractions proportional is 3. Now the next one. I'm going to cross multiply using the variables first. So I'm going to do 6x times 2x. And remember, 6 times 2 is 12. X times x is x squared. Equals, now I'm going to cross multiply the other way. That's going to give me 9 times 8, which is 72. Since I have an exponent 2 here, I must solve a quadratic. If I don't have a bx term, all I have to do is get x squared by itself. So I divide both sides by 12. X squared equals 72 divided by 12 is 6. And now I can take the square root of both sides. And remember, when I use the square root method, I must use plus or minus the square root of 6, and I am done. Okay? Now the next one, cross multiply using the variables first, means I'm going to do n times n plus 1 equals, now I'm going to multiply 4 times 5. I have to distribute the n, so I would get n times n is n squared, n times 1 is plus n, equals 20. Again, I have to notice that this is a quadratic, so I have like an n squared and an n term, so I must set it equal to 0 by subtracting 20 from both sides. N squared plus n minus 20 equals 0. Now if you go back to first semester and remember how to solve these using factoring method, right? We need to find the numbers that multiply to give us negative 20 and add up to positive 1. What numbers multiply to give me negative 20 and add up to positive 1? Okay, in this case, if I look, 5 times negative 4 will give me negative 20. 5 plus negative 4, right, will give me 1. So it's going to be n plus 5, n minus 4. And now all I have to do is set both of these equal to 0. So n equals negative 5, n equals 4. Both of these values of n will make these ratios proportional. So, next, when we solve ratio and proportional problems, one thing you have to look at is when you write your ratios, you must keep the ratios in the same order. Okay? Meaning, Myra's Meatloaf uses 4 pounds of hamburger to feed 6 people. How many pounds of hamburger will be used to feed 15 people? So when I start my ratios out, I'm going to put pounds of hamburger in the numerator over number of people in my denominator. So when I write my ratios, I have to keep this order the same. So 4 pounds to 6 people equals, I'm looking for the pounds of hamburger. So I don't know that, so I'm going to use H for hamburger. But how many people do I have to feed? 15. Well, now that I've set up my proportion, now I can cross multiply and solve. So 6H equals 4 times 15 is 60. When I divide by 6, H equals 10, which means it would take 10 pounds of hamburger to feed 15 people. This is where a lot of chefs use proportions on a daily basis. Okay? Next example. A 10-foot tree casts a shadow 20 feet long. A building casts a shadow 120 feet long. How tall is the building? So we're basically going the height of the object to the length of the shadow. That's the order I choose. It doesn't matter which order you do, as long as you keep it the same. So the tree is 10 feet, and that casts a shadow 20 feet, equals a building casts a shadow 120 feet. Where do we put the shadow? In the denominator. So that goes in the denominator. Do we know the height of the building? No. So I'm going to use B for building. So now, when I cross multiply here, 20B equals 10 times 120 is going to give you 1200. And when you divide by 20, right, B is equal to, B would be equal to 1200 divided by 20 is 60. So the height of the building is 60 feet. Okay, let's look at the next one. The scale model of a car is 14 inches long. The actual car has a length of 12 feet. Find the ratio. We're not solving a proportion here. It says find the ratio of the length of the model to the actual car. Well, we know this is 14 inches to 12 feet. But what is the big no-no here? Right? The big no-no here is the fact that the actual length of the car is in feet, not inches. So what's easier to convert? Feet to inches or inches to feet? Well, we know 1 foot is equal to 12 inches. So it's going to be a lot easier to say, well, 12 feet is equal to 12 feet times 12 inches in each foot, which is 144 inches. So we're going to say this is 14 inches to 144 inches. Now, if I go ahead and reduce that fraction, right, divide numerator and denominator by 2, and you would get 7 over 72. So the ratio of the model car to the actual car is 7 inches to 72 inches. Now these type of problems are found on the ACT exam a lot. The ratio of the measures of the angle of triangle ABC is 3 to 4 to 5. Find the measures of the angles. Well, the thing is, this is the ratio reduced. So we have to find out what did we reduce by. So what we do is we say the measure of each angle is 3 times whatever we reduced by, which is x, 5 times whatever we reduced by, and 6 or 4 times that. Now what do we know about all 3 angles of a triangle? All 3 angles of a triangle add up to 180. So in this case, we add them all up to 180. We get 12x equals 180. Now, when we divide by 12, we get x is equal to 15. So basically, right, if I look at this, the measure of this angle, 3 times 15, is 45 degrees. 5 times 15, right, is going to give me 75 degrees. And 4 times 15 would be 60 degrees. And what this means is, if you look, the ratio, that's 45. The original ratio was 45 to 75 to 60. But what they did is they divided these by 15, and that became 3 to 5 to 4. Okay, so that's how you approach those problems. Okay. Now this one, the ratio of the measures of 3 sides of a triangle is 3 to 7 to 5, and its perimeter is 156.8 meters. Find the measure of each side. Okay. So remember, the sides have a ratio of this. So we're going to say 3x, right, plus 7x plus 5x. When I add these sides up, right, and I take the original side by finding what we reduced by, that should be 156.8. So when I do when I combine these, 15x equals 156.8. Remember, we're dealing with perimeter now. So 156.8 divided by 15 would give you x is approximately 10.45. So the measure of each side would be 3 times 10.45, which gives you 31.35. Then 7 times 10.45, 10.45 times 7 would give you 73.15. And then 5 times 10.45 would give you 52. So we would do 5 times 10.45 gives you 52.25. And think about it, when we add these together, we would get that perimeter. Okay? Go ahead and take this lesson and attempt the homework, upload it, and then check your answers.